So, hello everyone. In this circuit, we will study how to control a double acting cylinder. So, what is a double acting cylinder? Basically, the fluid or compressed air enters the cylinder from two sides. So, it is obvious we'll require a 4 by 2 valve to control it. In market, 4 by 2 valves are not that available. In industry applications, we use 5 by 2 valves more. But for this, we use 4 by 2. 5 by 2 can be operated as a 3 by 2 4 by 2 both. How? By closing the other remaining ports which need to be closed. So let's start. So first, we have opened a new file in FluidSun. Now if you see in the hierarchical view, we get double acting cylinder. We select that. If you see there are some more components except the basic symbol of cylinder, we double click on it. We go in configuration, we remove cushioning and sensing. Next, what we do is, let me name the cylinder as A. This will be useful in the forward coming applications where I need to use roller control valves to actually signal another components. For that, rollers naming is very important. So here, what we do is, in the actuating labels, we name it as A0. The leftmost position, this position, I want to name as A0. So in this scale, it is 0. The piston position is 0 and here it is 100. So what I do is A0, A1. The forward stroke A plus, the end position I name it as A1. And the reverse stroke, last position I name as A0. Now 0, 0, 100 and that's it. That's the highest limit, 100 is maximum. Now, okay. Now you can see here, I have A0, A1 and 2 ports. Now, as we told, we require a 4 by 2 valve. So what I do is, I select the 4 by 2 valve. Now, this is the initial position of the valve. I connected here, I connected here. When the valve will be activated from the left hand side, this envelope gets activated, then we get the forward stroke of the piston. So what I do now is, the valve I am showing is pneumatically controlled. I want this circuit to be an impulse circuit. So what I do is, I show pneumatic connection here, and as always, as it is an impulse circuit, I show a spring return. Okay. Now, to control this 4 by 2 valve, I require another 3 by 2 valve. So I select another 3 by 2 valve. I can, instead of selecting this, I want it to be of push button type. So I directly select push button type. But we don't usually draw this push button in 3 by 2 push buttons. We usually draw that mushroom type. Well, this we draw in main switches. So what I do is, I select the normal push button. I select the push button. Now this will be supplied to the impulse circuit. So I select this and drag it to this point. And now we got a connection. Now what you can see is, here 2 ports are there and their inputs are missing. First, this will have an input as a pump. We give it as pump as input, and the second will be exhaust. So we can use a muffler for silent operation. It is air. It is a pneumatic circuit, so it can be exhausted from anywhere. Now, to supply this 3 by 2 valve, we require a compressor and a FRL unit. We join it as shown earlier in the earlier videos. To join anything, select one point, select the next point, left click on the first point, drag it to the next point. It automatically gets connected. That's it. Now I guess a circuit is made. Now we see the simulation. So what I see is, the fluid is coming from here, passing through the FRL unit, going to the 3 by 2. Now when the push button is pressed, the left envelope of the 4 by 2 gets activated. We get forward stroke of the cylinder. When the push button is released, the 4 by 2 due to the spring actions retains its original position, that is the right envelope, and we get the return stroke of the cylinder. Now I'll show you something else. There's a switch known as detain switch. So what happens is, normal push button, what you need to do is, when you press it, it stays only till the force is there. On the contrary, detain switch is a sort of thing which stays in its position until you press again. For example, I'll show you directly in the circuit itself. Now, instead of this push button, I use detain switch. Detain switch symbol is given here. Okay. Now, when I play the circuit with the detain switch, what happens is the supply is continuous. So it will only do the forward. Let's start. That's it. I need to click on it again to come back. So that is the application of detain switch. In bigger circuits, we use detain switch so that the once we switch on the circuit, it goes on continuously on off, on off, on off. Forward show, return show, forward show, return show, until and unless we want to stop it again, then we press the detain switch again. This was a simple tutorial, guys. Hope you liked it.